Okay, good afternoon, everybody. And this is really the introduction for the last lab. Now, this last lab is very short, and we will not have any formal lab reports. It's just you are going to follow the instructions and submit your file here. Now, I will go to the this page where I'm gonna talk about some of the things that we are going to talk to include in this chapter, in this lab. Now, something that I want you to know that we did last week RC circuit and today RL circuits. Now, stands for what is called inductors, or like the quantity, the physical quantity, it is inductance. Okay, then our circuit is going to include today a coil, which is like an inductor here, L, and a resistor R, and a voltage source that is going to be AC. Okay, then I will say this is not a formal lab report. You don't need to include an abstract or equipment list or procedure or conclusion. We will find here that your report should include a Word document with the following: the data from the experiment in tables, the calculations listed in this lab manual, and the results in tables with correct number of significant figures. All right, now let's here talk about more. You are not required, of course, to calculate any uncertainties because this is not a real equipment. You will refer to the material from chapter 30. Now, in the theory here, we have an inductor that has a value L. L is the inductance, and it is measured in henries. And when it is connected in series with a resistor, the current will flow, and the voltage across the resistor as a function of time is going to be V as V as a function of T equals V maximum times 1 minus E minus T to the divided by tau. And we will see that the current is going to increase. The thing that we need to know,
I couldn't hear what you said.
okay, the thing that I want you to know here, that this is an experiment that we did exactly very similar to the experiment that we did before, which is the RC circuit. And we will have two sensors that they're gonna measure the voltage across the resistor and across the inductor. Now, tau here, which is the time constant again, and it has units of seconds, it is L over R. We know R, then we will be able to get what is really the value of L. Now, tau here, again, it is, as I said, the time constant. Now, during the discharging, Vt is going to be V maximum E minus T over tau, and the current is decreasing. Okay? Now, we will say here, in our case, like our inductor was like 880-10 coil, mounted in an iron fixture. This is really, we use it, a technique, so that we will have more inductance. The resistance is a decade resistance, and it is 10,000 ohms. The time constant, again, it has the same definition, is the time takes the voltage across the resistor to be 63 of its maximum value. And it is the same time, the time constant also will be equal to the time takes the voltage across the resistor to be the 37% of the maximum value. When the current is decreasing, then we can find two definitions for tau. By measuring the time constant directly, the value of the inductance can be determined if the resistor value is known. Okay, to study, of course, our objective is to study an RL circuit with an AC power supply to determine the time at which the value of the output voltage is 37. Then we will calculate through the, I will say, what is called the discharging, okay, which is that one here, this equation 3. Okay, then we will determine tau, which is the time at which the value of the output voltage is 37%, the value of the input voltage. And then after that, we will determine the value of L, which is called self-inductance of that inductor that we are using. Of course, the resistor, it is 10 kilo ohm. We have function generator to create a square wave that is going to be our input. We're going to have a coil that has an iron core and it has 880 turns. We have a computer, Pasco, interface, and wires. Now, we will use the graph provided to record the value of the maximum voltage, and that is called V1. And we will record the value of the time at which the maximum voltage occurs. We will call this T1. Remember, this is going to be your data. We will record the 37% value of the maximum voltage display in the graph, and we're going to call it V2. And then we are going to record when this voltage is going to occur. We will call this T2. Okay, this is going to be included in your data section. We will calculate T, which is T2 minus T1. This is going to be our tau. And we need to subtract the time because we don't have the maximum voltage at 0 seconds. Okay, if it was like starting from 0, then you don't need. Yeah, now using tau from the above, find the value of the resistor, and the value of the resistor, we will be able to calculate L, the inductance. Okay, and we are going to include the units. Okay, and this is what we should have in our lab report. Let me share with you what we are going to do with the graph. The graph here, it is this one. And you can see we did like most of the work for you. This is our input, okay, which is a square wave. And this is really here the what is really measured as the voltage. Okay, now this is the maximum value of the voltage, 9.996, and it occurred at 3.36 10 to minus 4 seconds. We took 37% of this value, and this is the value here. And then we will find from the graph what is really the time here. Then this is my T1 and this is my T2. We are going to subtract to calculate what is really tau. And remember here, you know, like you have, you have all the equation for you here. It's just one equation. You don't have to worry about so many things. Tau, it is L over R, and R, it is 10,000 ohms, and then you're good to go and calculate L. We don't have here a theoretical value or like, you know, 2 methods to calculate L, and therefore we will not calculate any percentage differences. All right, thank you very much. And this is the last experiment. And I wish you all the good luck, and I enjoyed teaching you. Thank you.